Hello everyone, and welcome back to the course. In this lecture, we're going to go over the answers for the NumPy practice activities that we went over in the last lecture. Let's jump on over into Jupyter Notebook and get started. Okay, so here I am inside of our practice activities notebook. Our first question was on importing NumPy, so we can go ahead and say import NumPy as NP. And with NumPy imported, we're ready to start with our main questions. First, we have to create a one-dimensional array which contained 3 numbers. To do this, we can call our np.array function, and then we'll just pass in a list of our 3 numbers. So 1, 2, and 3. And then here is our output below. And then we moved on to looking at how to create a 2-dimensional array. So with an extra row of 4, 5, and 6. We'll again start with our np.array function, but then for our arguments, we'll pass in a nested list, or in other words, a list of lists. So our first list will be 1, 2, and 3, and then for our next list, we'll have 4, 5, and 6. Perfect. So that is how we can create a 2D array or a matrix. And then I'll just go ahead and store the result of this to a variable. I then asked you to look at the shape and data type of this array. And to do this, we could have used the .shape and .dtype attributes respectively. So shape returns a tuple of 2 and 3, where 2 is our number of rows and 3 is our number of columns. And then for the data type, we'll just say our array name .dtype, and this returns int 32. So the data type for each element inside of this array is int 32. Next, we had activity 2, which was on how to create arrays using functions. For the first question in this activity, we had to create an array of 20 ones. I hope you remembered that we can use the ones function to do this. So we can just say np.ones, and then in our parentheses, we can say how many numbers we want. So I'll put in 20, and then this will return an array of 20 ones. The next question is pretty much the same, but using the zeros function instead. For this next one, we have to create an array of integers going from 1 up to 100. To do this, we could have used the arange function that we looked at earlier on in the section. By default, the arange function starts at 0. So we'll need to set a manual start value of 1, and then for our stop, we'll set this as 101, as the stop value is not included in the range. And then if we run this, here is our output. This next question was a little trickier, but could still be done with the arange function. This is similar to the last question, so again, we'll start at 1 with the same stop value of 101, but this time we'll add in our third optional step argument, and we'll set this to 2, and this will mean that our numbers now go up in jumps of 2. And as we started at 1, this will then work out to be all of the odd numbers between our start and stop value. There's a couple of ways that we could have gone about doing this next question, but I gave a hint of using the np.ones function that we've covered previously. If we call np.ones, this will of course return an array of only ones. But if we multiply our result by 5, this will then create an array of 5s for us instead. And then we had to create a 5 by 5 matrix with numbers ranging from 0 to 24. The arange function will be perfect for creating our range of numbers. So we'll say np.arange and then 25 numbers, and this will return a vector. So let's reshape this to a matrix with the reshape method, and we'll just say 5 rows and 5 columns. The final question for this activity was a little bit different. Given the example output provided below, we had to create an array that matched it. And there were quite a few steps involved in this question, so if you had to reference the solutions notebook or Google, then don't worry. To start with, we can see that we have 10 numbers going from 0.01 up to 0.1. So this is a range of sequential numbers, and we know that to create a range of numbers, we can use the arange function, so we'll start there. What we could do here is have our numbers start at 1 and finish at 10, like this, but then we can divide our result by 100, and this will then get the numbers that we needed for our output. And then to turn this into a matrix, like we have here, we'll just reshape it to have 2 rows and 5 columns. Okay, and great job so far. Our next activity was on random number generation. So we'll be using the 3 random functions that we've looked at so far. Starting out here, I asked you to generate a random number between 0 and 1 with a uniform distribution. Hopefully, you remembered that to create a random number with a uniform distribution, we can use the rand function. So np.random.rand, and this will create a random number between 0 and 1 with a uniform distribution. To create a matrix or random numbers, but this time with a normal distribution, we could use the randn function, as opposed to rand that creates a uniform distribution. As we're creating a matrix, we'll need to pass in an argument here. So we'll just say that we want to have 4 rows and 4 columns. And to create random integers, we can use the randint function. And that's what we'd have needed to use here. For our arguments, we needed to start at 1, so we can provide that here for our low value. And then for our high or stop value, we'll say 101. And remember, that's not inclusive, so this will actually stop at 100. And then to generate 10 numbers, we'll have to provide a third argument, which is the size. Moving on to activity 4, which is our final activity for this notebook, we were looking at indexing and slicing. And to start off here for our question on indexing, we've been provided with a basic array called array1, which is just 5 numbers from 10 to 50. The first one was quite easy, so we just had to print or index the second element of our array, which would be the number 20. And to return this number, all we'd have to do is index our array at index position 1, and this will return our number. To return the last number, but with negative indexing, we can just say that we want index position -1, and this just works in the same way as it did for our regular Python lists. Moving on, we needed to have a look at slicing. And again, for these questions, we had an array called array2, which was just a list of numbers from 1 to 10. To print the elements of 3, 4, 5, and 6 from this array, we would need to extract index position 3 to 6. So you can just say array2 from index 3, and then a colon, which starts our slice, to index position 6. And again, I've mentioned this a few times now, but the reason that we sliced position 6 and not position 5 is because the stop value for our index is not included. So we have to have one index further than the value that we actually want to extract. And then we had a slightly more complicated slicing question where we had to slice this matrix here. So we've got 3 rows and 3 columns with numbers going from 1 to 9. To start, we had to print row 1 and 2, so numbers from 1 to 6. We can just specify our first 2 rows, which would be from index 0 to 2 for our slice. To print 4, 5, 7, and 8, which are the numbers in our bottom left-hand corner, we would need to extract rows 2 and 3. And then from these rows, we need our first and second columns. And just to clarify here, I'm referring to the actual number and not the index number. From here, we just need the first 2 numbers, so the first 2 columns. So we can add in another set of square brackets for our column slice, and then we'll have this be from 0 to 2 for our first 2 columns. Okay, perfect. And we're getting close to finishing this section here, but we just have a few more questions to go. Using the same array1 variable as we used earlier, we needed to create a Boolean array for the elements that are greater than 30. So this was quite a simple one, and all we have to say here is array1 and then greater than 30. So any number greater than 30 will return as true, and anything less will be false. Then I asked you to index this array by using this condition as a Boolean mask. We'll just call our array, and then inside of the square brackets, we can pass in our Boolean condition, and then this will just return any numbers inside of the array that are greater than 30. To broadcast 100 to the first 3 elements inside this array, we can just select the first 3 elements by slicing, so from index 0 to index 3, and then say that these are equal to 100. And then just to finish off, we had a few questions on universal functions. For these questions, we had to take this array here, called array3, which just contained 50 numbers between 0 and 14, and then take the square root and square functions and apply these to this array. To call the square root function, we can just say np.sqrt, which is short for square root, and then pass in our array inside of the parentheses. And this will then output the square root for each element inside of our array. And then we can do the same for square, but this time by using the square function. And then at the bottom here, we have to create 2 randomly generated arrays with the code provided here, and then use the maximum and minimum functions to find the maximum and minimum values at each index for our arrays respectively. We can just say np.maximum and then provide our 2 array names, which were array rand1 and array rand2. Your numbers will be different to mine here, but if you look at what numbers you had inside of your arrays up here, you'll see that this function has returned the maximum for whatever you had at each index. And then the minimum function will just return the smallest value instead. Okay, and that's everything there for our solutions lecture to the NumPy practice activities. And again, like last time, we've covered a lot of content here in this section. So if you need to, then please feel free to go back and watch any of the lectures again, or post any questions that you might have down in the Q&A section below. Let's go and take a well-deserved break here, and then we'll come back in the next section and we'll begin looking at pandas, which will be one of the most important libraries and topics that you'll need to know when doing data analysis tasks. Thanks everyone, and I'll see you all in the next section.